So among the probability sampling, remember with probability sampling means in all these methods we assign different probabilities, we assign different numbers. All right, so all these we assign numbers. And then we choose randomly. That's first one. Simple random sampling, assign number, then choose randomly. Which means every outcome has an equal probability, equal chances of being selected. Then we can have sampling, a systematic sampling. Systematic sampling that first we already decide the system that in, for example, in first row there are 6 students and I'm just gonna select every third of it, every third student. So which is also randomly, means every student has a possibility, but every third student in a first row, in every row, has a possibility of being selected. So that's a systematic where I define system. Stratified sampling is like I distribute the whole n into different stratum. So for example, population is come up with different heterogeneous groups. There are different kinds of people, like some are teachers, some are uh, taxi drivers, some are fruit sellers. So they are different. So what I do, I just divide them into different stratas. That if someone I pick is like a taxi driver, so I will put in that stratum. So we will see. And then cluster sampling. Cluster sampling, we divide the population in different clusters. Cluster means group, in different subclasses. And then there are other sampling methods. So let's talk about these stuffs to better understand that how do we choose small n from big N. Yeah, so this is all the game of choosing the sample. Well, now before that, what is probability? Probability is the likelihood, again, is a likelihood of being selected. That means chances of occurrence. For example, as I told you, the class example, there is another example of lottery. I will assign each one of you number, like your ID number. Your ID numbers are already assigned to you, right? Your student ID number. Now I collect all those ID numbers and put write on a piece of paper, and each paper I put in a box. And I pick randomly. Now, within a box, every student has an equal possibility of being selected, right? So that's probability. What is non-probability? No random selection, neither can an existence of chances. So here in non-probability sampling, all your preferences, like your choice, you just select one student to give the award. You understand convenience sampling, right? Based on your comfort, based on your convenience. You understood judgmental sampling means when you judge people based on their knowledge, right? It means you ask expert opinion from an expert. So you're gonna select the expert from the population, big population, and the small n will be the number of experts. Quota sampling, when you define certain quota to certain characteristics, that's quota sampling. Now let's talk about snowball sampling. What is snowball sampling? Um, there can be different kind of snowball. As I told you, when your sample is really rare, it's hard to get. It's hard to get to them. Means there are very few people who have this kind of characteristic which I'm interested in. So then what do I do? For example, I want to ask the information from my students whose father is working in a multinational company only. It's really hard to get it, right? Really hard. I mean, not I don't know, maybe in this class, maybe one multinational, international company, maybe one or maybe two students, their father are working in an international firm, maybe. I'm not sure, it's just an example. So how to do that? How to choose then this and? First, their first method is linear. snowball sampling. So in linear snowball sampling, I ask one student, which I know, then this student, he refers me another student. He tells me that, oh, I know another student, you can also ask them. You can also ask him or her. And this student, let's say I want to ask from students who are playing basketball, right? So not everybody plays basketball in the class, right? In my class, but one student I know that he plays basketball. So I ask him, and he refers me to another player, and then another player refers me to another player, then another, and that's how I keep selecting my n. So that's a linear. Linear means straight line. So within a straight line, one refers another, another refers another, another refers another. So that's how I built my small n. Understand? Whereas exponential are non-discriminative. Remember, non-discriminative, where I don't discriminate. So far, it's not my choice. My choices are not in there. I'm just following what people are referring me. So exponential means when I ask one person and he refers me two people, then I go each one of them, and each one of them will tell me two more, and then each one of them will tell me two more, right? So that's how I continue. That's how my n grows faster than linear, right? And I can have a good n sample quickly. But of course, I need to put a lot of resources in doing that, right? So that's, but I don't discriminate. Whatever you tell me two, I go for two, right? Then each person tell me two more, then I go to them as well. But here, just like a judgmental sampling, in exponential discriminative snowball sampling, that's the problem. Here I bring, so one person I ask, and this person refer me two people, that one guy living nearby and one girl living a bit far. So I say, okay, yeah, he told me about these two that who are also basketball player, but I don't want to know about the to go too far away, so I choose this one. So this portion goes, I don't consider this portion, right? I don't prefer this one. So I just go and ask him, and he tells me two. So I say, okay, I don't go this one, I go to this one. And he tells me two. So I do go this one, I don't go this one. So I don't follow the outcome reference. That's a discriminative snowball. Do you understand? So that's how I collect my N. But same again, based this in this discriminative, I discriminate. For example, another example, let's say, uh, okay, this is a bad example, but just to make you understand. So one guy referred me two people who are working in an international company, but one is a educated person and the other one is an uneducated person. I say I don't like an educated person, I go with educated person. Right, so there can be a misrepresentation also in this kind of non-discriminative, in this kind of discriminative snowball sampling, because here there's a personal choices are there. Another example of, you can also consider COVID-19. So one, I need to collect data from COVID-19 patients. So my N is like gonna be constitute of COVID-19 patients. So I ask one student, one patient, he will refer to me another patient, because I don't know who is having COVID-19, right, in the past. But one patient, he tells me, oh, that my friend also got COVID-19. I go to him and ask question. He tells me that, oh, another person. That's how governments, they find that people, how the COVID-19 spread, because then people tell them that these people also got like COVID-19. So I got it from them. So that's how they control. So it's, this sampling is also good to take control measures. All right. Do you understand? It's easy. So non-probability sampling has convenience sampling, judgmental sampling, quota sampling, snowball sampling. In snowball sampling, there can be different techniques: linear snowball technique, exponential non-discriminative snowball technique, and exponential discriminative snowball technique. So before going to the probability sampling, or we just go to probability sampling, what do you think? So before going to probability sampling, let me tell you one more thing. This is going to be your homework. So mostly it deals with until the non-probability sampling. All right. So probability sampling is not included in this homework. You will get the slides and you will find out. Now let's talk about the types of probability sampling. That's really important because that's the sampling you're gonna mostly deal with in your practical life and also in your student life. So first one is a simple random sampling. As from the name, it means it's really simple. How simple it is? Let's see. It's simple random sampling is actually a sampling scheme with a probability that of any of the possible subset of the sample is by means of table of random numbers. Once a sampling frame is available, each person in the population is assigned a number. The same example as I told you in the class 10, right? I give each student the student ID, right? And from that student ID, if I'm going to select uh, four student IDs randomly, sorry, that's mean everyone has an equal chance of being selected, but someone will get lucky and someone won't. That's simple random sampling. After assigning a number, any person from the given population could be selected without defining any kind of order. Means any kind of order means when even I can select a poor student for the best award, best student for some punishment, right? So that's the problem with the simple random sampling because there is no certain order. So we cannot say it's fair or unfair to choose the way we are choosing the sample, but it's a technique, and mostly we use simple random sampling to conduct different surveys. Same, you can repeat the same thing to understand of a lottery example. Now, one thing, choosing randomly without any bias from the researcher. One thing is for sure that there is no biasness from the researcher. There is no personal opinion. There is no personal preferences. There is no personal choice of a researcher. So everything is based on random process. That's a simple random sampling method. Another one is a systematic sampling. As I told you, it's like a selection with a fixed interval, right? For example, in a class of 10, there are 10 students. Let's say there are 30 students, class of 30. So we have 10 students, 10 students here, or let's say 7 students here, 7 students here, 7 students here, and 7 students here, and 7 students here. So let's say 35 students. 1, 2, 3, 4, 5. Yeah. So what I do, I already decided it in my selection of a sample member out of population in a systematic way. What is systematic way? That I already decided that I'm going to choose the third person who is sitting here, right? Then third person is sitting here because there are 7, so 3, and then I will select 2 people from here, right? And then 2 here. So that's how I select. So every third person, if I select from the row of 7 students, which means I am giving a fixed interval. This is also known as a sample interval. So when I consider sample interval, that's a systematic sampling. We can also say that systematic sampling is a type of a probability sampling method in which sample members from a larger populations are selected based on according to the random starting point, but with a fixed periodic interval. So here is the interval is 3, means gap of a 3 students or 2 students, right? That's a fixed periodic interval. This interval, which we all said that is also called like sampling interval, can be calculated by simple rule. How do we calculate this sampling? That what is the difference? Why third row? Is it like by my preference or is it just like some formula? So we can remember K denotes the class or group. So I can just use this formula to calculate the sampling interval. So if my population is 35 and I want to collect the sample of 7, example, so interval will be 5. So after every 5 students, I will pick the student. I say, okay, you come out, then you come out, then you come out, then you come out. And hence I will select 7 students from 35. Balama. Do you understand? So that's systematic sampling with where we have a systematic sample. Now let's talk about stratified sampling or stratified random sampling. So this systematic sampling is also random. Sorry. Now what is stratified sampling, random sampling? Stratified random sampling is the process of dividing members of a heterogeneous population, as I told you. Our population is consists of various people, right? So first we define different homogeneous group. That these people they belong to the taxi driver strata, these people they belong to teacher level strata, and these people they belong to artist class. So we just build like homogeneous groups, homogeneous strata, similar strata from a heterogeneous population. Homogeneous groups from heterogeneous population. Right? So after dividing, now we define the homogeneous group means with the same traits or subgroups before sampling. Now this we do before sampling, right? At the moment, I didn't choose anything. I didn't choose any person. Then what do I do? The strata should be mutually exclusive. So there are 3 things to remember in stratified sampling. One, make the homogeneous group from heterogeneous population. Second, it should be the strata, the group, this homogeneous group. This should be mutually exclusive. What does that mean, mutually exclusive? Mutually exclusive means that every element in the population must be assigned to only one stratum. It not like that I someone said that I'm also an artist and I'm also a teacher. Then I have to assign him either in artist group or in a teachers group, right? I cannot assign him in 2. Like I cannot say that he's also in a teachers group, and he's also in a artist group. So that's I cannot do. So mutually exclusive means one in one stratum, right? Do you understand? Every element in the population must be assigned to only one stratum, not more than one. The third one, which is very important, the strata should also be collectively exclusive. Sorry. That is, no population element can be excluded. So we can consider all the population. So here we can select n. That's how we first define n. We divide n into small heterogeneous population group, and then which are mutually exclusive means one is not repeating in another group. Then collectively exclusive means each and every person is included in these groups. And then we choose randomly the small n from each data, right? That's a stratified sampling. Now, cluster sampling. What is cluster sampling? As from the name, it's clear. You have to draw different clusters. Yeah. So cluster sampling, make cluster. It refers a type of a sampling where we define different cluster. So we divide the population into separate groups. So it doesn't matter it's heterogeneous or homogeneous. So in stratified, we have to divide the population into homogeneous group. In cluster, we just separate into different groups. But there can be some problem. Like let's say this is my class where different students sitting together, right? So I define this cluster. But in this cluster, there are only 2 students, and in this cluster, maybe there are like 7 students, right? So that's also a problem in cluster sampling. You see, so the number can be low or can be high, depends on the region where you are constructing the sampling. Once you divide into different cluster, then simple random sample of cluster is selected. So what do I do in this? Means that's the class of 100 students. I make these clusters, right? So from 100 students, I make 10 clusters randomly. Then I choose. Now I assign the number to each cluster. Before, in simple random sampling, I was assigning the numbers to each student. Now I'm assigning the number to each cluster, and I choose the same way as I used to choose in a simple random sampling. That's a cluster sampling, right? So this, mostly the researchers conduct this analysis on the data from the sample data rather than population data. So let's say I choose these 3 out. So all the numbers in these 3 clusters, that will be my small n. Right now, there can be only 1 person here in this cluster, and there can be 3 students here. There can be 4 students here. So 4, 3, 7, and 8. So my n will be 8. Whereas there can be 10 students in this cluster, there can be 15 students in this cluster, and there can be 5 students in this cluster. So if I could have chosen the next 3 randomly, then my sample size would be different. So that's why researchers choose always if they want to analyze the sample, they make cluster first. Most of the business studies, like in international business, we make different studies. For example, if I need to calculate, if I need to find out that how many people they trust in the platform of the mobile phones. Platform in mobile phone means like Alipay, like WeChat, how many people trust them to do transactions, or Taobao, right? Or there's another JD, right? JD.com. So these are the platform where people can buy and sell. So how much people trust in them? Sorry, I cannot know how, because there's a big population. So what can I do? I can make just a cluster. For example, there are 50 students. If I divide students into 10 groups of each randomly, and now I need 15 students, so I choose 3 clusters. Understand? Do you understand? Let me see if you understand or not. Do you understand me? Yes, perfect. What is this? Oh, this means yes? Okay. I didn't know about that. Okay, anyway. So now in probability sampling, in non-probability sampling, there are different methods, right? Convenience sampling, judgmental sampling, quota sampling, snowball system. So whenever in future you're going to conduct any survey or any primary data collection, you can choose this, depends on what do you want. And in probability sampling, simple random sampling, that, right? Assigning equal probabilities, choosing randomly without any bias from you yourself. Systematic sampling, sample members, selection of sample members, similar sample members out of population in a systematic way, having fixed interval. You can get the interval through this formula. Stratified, when there is a heterogeneous population, make a homogeneous subgroup, then do it. Must be mutually exclusive, no one exclude. Cluster, make cluster, choose cluster through random sampling. So that's the basic sampling techniques. You collect the data. Now, after collecting the data from these sources, you need to do something else. What do you need to do? You need to prepare the data, right? You need to fix the irregularities. How to fix an irregularity? So sometimes you have a data, let's say you collected the data and the data is like from 2010, 2011. Okay, now I'm not gonna start from 2010 because I don't have space. So years, 2015, 16, 17, 18, 19, 20. How beautiful is my handwriting? I didn't know about that. Okay, anyway, so especially when I write on the computer. So now I have years. So let's say I have collected the data for X variables, for X factor, and I have data like 3.4, 4.3, 9.2, missing, 10.2, 3. Oh, sorry, 10.7. So this data is missing. Now that's a problem, right? And I want to know about 2021 as well. This is also missing. But how to calculate, how to fix these kind of, so mostly we get this kind of data in a secondary data set. How to find these kinds? So there can be 2 ways. One is interpolate. Let me wait. Where is the Where is that example? Okay, let me tell you. So you can see the screen, right? Let me make it bigger, a bit bigger. Okay, that's good. So we have years 2010, and there's a one variable x, any variable, right? So there's a value 3.4. Why is like this? 3.4. Seriously? Oh, I know. 3.4. Okay, good. It doesn't matter. So we can go there just to understand. So we have 3.4, 3.6. How to do that? Good. 3.7, missing. 4.5, 4.9, 5.8, 7.2, missing 9.1, and I don't know. So this is missing, this is missing, this is missing, this is missing, right? How to do that? So there are different ways. So when we have a data which is missing, in between the data, we need to interpolate the data. If the data which we are looking is missing, and that means for the future, then we have to extrapolate. Not always, but sometimes we need to. How to do that? There are different ways. So I'm going to tell you one way. So if there is single entity missing before and after the data, so how to do that? There is a formula. First, what you do, you're just going to use the formula previous plus previous available data, plus next available data, which is this one, minus previous available data, which is again this one, right? Divided by 2, and that's it. So this will be our missing value. So this one is previous. Oh, I need to do this in this way. Yeah, this one is okay. Then I need to do this way. So this one. So what's the formula? When we need to interpolate, you can note it down. Previous available data plus next available data minus previous available data by 2. So you calculate this thing, then you add into previous. That's how you get the interpolate. But sometimes, as you see, sometimes as you see that you can have missing data of 2 missing data. So here, the same thing, you're gonna do the same thing, right? You're gonna copy, you can copy this because in Excel they can go back. But here, oh, why it's not copying? So let's do this. Previous plus next minus previous. But here, next available is not B8. Next available is B9. Right? And previous is the same. So we divide by, here we divide by 3 because there are 2 missing. So we're going to divide by 3. So it's going to give us 3.96. And here, I'm going to just copy this here, which is the same. But here, I'll have to use, next is B6, B9. And here, I will do 2. So that's how we can get the interpolate. So now our missing data is there. How to extrapolate? You just get the data from growth. You can use this formula. Growth how to do that? Oops, what's wrong with this? So known years. So how many known Y, right? So how many X do you know? Right? So you know these X. Okay. So these are the known X you already know, right? But you don't know the X for 2021. Then you're gonna put colon. You're gonna know known years. So you know the years up to 2020. So which year you don't know, you wanna know, then you put like the last year here, which is 2021. This is C15 is 2021. Okay, then enter. So you will get the extrapolating the data from year 19 for year 2021. So that's how we also project the future value. Understand? Do you understand? Use the function to calculate the approximation, but this is like a perfect, like to mostly used by the researchers to interpolate and extrapolate the data. Because there but you need to mention it once you interpolate or extrapolate. You need to mention in your study that you have done this, because for example, a lot of education data is missing. So then you need to do that, and you can put a note that education variable, we also interpolated the education variable for the missing values. Then the reader will know. Then you have to format the data. There are different ways to format the data. First, structure the data into Excel form. Like you have to properly put it in a year ways and variable ways and make it in a table form in Excel. Then what is stacked and unstacked variables? For numerical variables, number variables, to change the data into subgroup. For example, to divide the salary income from population, you want to separate the data for male and female. I have a data. I have an income data of total population, but I need to separate for male and female, right? So female, I will write. So I need to define the data in this such a way, right? This means first I need like total. I have total, so I need divided total into two subgroups. If I want to separate the data for male and female, in this case, we change the data into unstacked or stacked arrangement. For unstacked, we use different numerical variable for each group, or we can create male and female income as I did. Now this is unstacked. And for stacked, in this case, the data is given already, right? So you don't need to change the data. Then what is recoding the data? Recoding the data means assigning the new value. Assigning the new. This is a new value. For example, when there's a variable of x, right, and you need to smooth the data. Like the x has different data, 3.2, 3.4, 3 point something, and then suddenly like a jump, 98.2. See, now this is an outlier. So how to smooth the data? We just create a new variable. We assign a new variable. For example, that will be log of x, right, equals to ln of x. And we can create this. So it's also representing the x, but in a smooth way, right? So assigning the values. Similarly, like when we have like, I can say, I need a data from a student who are rich only, right? So I will divide my population by my n into rich student and poor student. So rich students with good marks, poor students with good marks. So if a student with good marks and is rich, so it's just an example, okay? So I just give 0, and if the student is poor and having a good mark, so I mention 1. So now I assign the new values to the same variable. So that's how the stacked variable does. That's how we do the recoding. Now, what is the error? Error, whenever we measure something, there is always an error. Sometimes it's a coverage error. Coverage error means selection of a certain group out of the frame. Selection bias. For example, I say there is a competition tomorrow in the class, and you ask your friend from another university to join the competition. Now he's an error term for me because he's outside from the population. He's not from the population. Or sometimes you ignore a person who is in the population, right? You don't take it. That's a coverage error. Non-response error. Like you don't, sometimes you collect the data from population and then they don't respond to you. Then your variation being selected. And sometimes what you do, if you can see me, so sometimes what you do, you can use it's also known as proxy error, which is measurement error. Like for example, we have infrastructure, right? How to measure infrastructure? Infrastructure includes many things. It includes buildings, roads, hospitals, many things, right? But we cannot do that. We cannot measure hospitals, right? Okay, we can say number of hospitals, but we at the same time the telephone lines. There are different ways of infrastructure development. What we do, we simply use one thing to represent the whole thing, and that's a proxy. Proxy means when you use one thing which can reflect the whole thing. I'm gonna just consider the number of bridges in the country as a sign of infrastructure. So that can be different. So you can think that, oh, no, number of hospitals can be infrastructure, a good proxy. So we can debate about that, what is good proxy and what is not good proxy. But we can select any proxy which can represent. So here there can be a problem of measurement. Like there can be a lot of errors while measuring the number of bridges because they're huge in numbers. So sampling error variation is a variation error, like how much varied your observed value. From n, you get like observed value of mean, which is like 21. But when you take the actual mean, the value is like 23. So the difference between 21 and 23 is like 2. This is my variation from my observed and from my estimated. So observed is 23, my estimated, which I estimated through sampling technique and using the formulas, is 2 units less than the actual. So what is this? This is an error. So I did it because of some reason. So, next we will do further that how to, what we learned that measure the skills. So tomorrow we will talk about that. Tomorrow it will be like how to represent the data, which we have collected through different techniques. Now, if you have any question, you can ask. I have successfully recorded these lessons, and I'm gonna upload it to the group soon. Okay. So if you have any question, you can ask.